All right, so today we're going to look at our sample midterm number 2. All right, so now remember, this one is just chapter 8. It's not quite as long as the previous one. So let's get started. And then we can get back to chapter 11, where we're about 3/4 of the way through chapter 11, maybe even more. We're getting towards the end of it. But right now we want to focus on our sample midterm number 2. Again, only based on chapter 8. And then when we're done with this, I can post the actual test, and it'll be the usual. You can have a week to do it. It won't be that bad. But anyway, first of all, what is an annuity? This is a regular stream. See, there's a lot of ways you could describe this. Let's call it, no, I have a better idea. Let's call it a periodic stream of equal payments. That should do it. That way it's accurate, but it's also very general, because you might recall that sometimes when we have monthly car payments, for example, we think of that as an annuity, even though technically the word annuity means annual payments. We often use the word to describe any regular payments, as long as they're all equally spaced apart and as long as they're all the same size, that could qualify as an annuity. All right, simple interest. Okay, this is interest paid on principal only. All right, there's no compound interest. You're just getting interest based on your original principal with simple interest. But then with compound interest, this is the one where you get interest on interest. Okay, so normally you earn some of both. It depends on the circumstances, but usually you end up earning some of each. And so the total interest is, of course, the sum of simple and compound. But simple interest by itself is the interest that you receive on your principal. And then compound interest is interest on interest. That's the one that grows as we keep increasing the compound frequency. All right, so APR represents simple interest only. Okay. So when you go into the bank and they show you both numbers, you know what they're paying on your principal. But that's not complete information, because you need to know how much you're actually earning when we take into account both simple and compound interest. So EAR, or effective annual rate, represents both simple and compound interest. So in other words, this is the sum. This is what you're actually earning. So that's why this is so important. And we saw with our examples that you might have an APR, let's say, of 6%, but when you take into account the compounding frequency, it'll be more than that. It might be 6.3, for example. And that's important information, because it tells you exactly how much you're earning in this account. And of course, when you're borrowing money, you also need to know to find out exactly how much you're earning, or paying rather. Now, for an investor who keeps a 5-year CD, which measure provides a true rate of return, that would be the EAR. In other words, the APR is only showing you how much simple interest you're earning. So it's not complete in the sense that it's leaving out the compound interest, which is not good. I mean, it's good. It's important to know that number, but what really matters to the investor is that this is the number that you're actually earning. Okay. Now, what about this one, G? APR and EAR are only equal to each other when interest is compounded annually. And you can tell, we went over this. If you look at the formula for calculating EAR, you can see that if we only have one compounding period per year, then these two numbers will exactly match each other. Other than that, EAR is always larger than APR. Okay, now it doesn't ask you for that, but it's good to know. Now, as compounding frequency increases, what happens to the simple interest? Okay, the simple interest does not change when the compounding frequency increases. Okay, it is completely independent of the compounding frequency. It's the compound interest that changes, not the simple interest. So the key word here is simple. And of course, remember the formula I equals PRT. I equals PRT does not contain the compounding frequency variable, which is n. So therefore, it is completely independent of the compounding frequency. But on the other hand, you can see here, this is the follow-up question, I. The compound interest increases as the compounding frequency increases. Okay, we've seen that many times. The more often the interest is compounded, the more compound interest you'll earn. Okay, so if you're borrowing the money, you want the compounding frequency to be very low. If you're lending the money, you want it to be very high. Now, here's a math question, a quick math question. For a deposit of $10,000 at a rate of 5% for 2 years, how much simple interest is paid? Okay, well, that would be this case. I equals PRT, as we've mentioned, which means the principal is $10,000. That's how much we're depositing. The rate is 5% per year, and the money is kept in that account for 2 years. And when you multiply that out, that gives you $1,000 worth of simple interest. Okay. So far, so good. So these are all pretty straightforward. Now, here's an interesting one. And then we'll jump into the actual problems here. For how long would a sum of $5,000 need to be deposited in order to earn $1,000 in simple interest with a rate of interest of 5%? Okay. So the sum is 5,000. The interest is 1,000, simple interest. The rate is 5%. So here's what they're saying. What is the value of time? So if you recall, since I equals PRT, that implies that T equals I over PR, which equals 1,000 over the product of 5,000 times 0.05. And don't forget those parentheses when you're using your calculator. And that works out to be 4 years. Okay, 4, which means 4 years. Now for the next group, we're calculating the future value of the sum, but if you notice, each one of these has a compounding frequency associated with it. And so that is a hint. Oops. Hold on one second. That's a hint as to how we're going to approach this. In each of these cases, we're going to use our formula. Let me throw that in here. Give this thing a second to wake up. A equals P 1 plus R over N to the NT power. NT, okay? This is the formula because we are allowing for the possibility of compound interest. Okay, so for all 4 of these, we're going to use this formula. So let me split the screen so you can see what we're doing. So for part A, we're told that P is 1,000, B is 0.05, not B, what am I saying? R is 0.05. The compounding frequency, as you recall, is that N, and then T equals 2. Okay, now all we have to do is plug in these numbers. And of course, we have to be careful, very careful. So let's do that. So the principal is 1,000. Then R is 5%. N is 2. And then we have in the exponent 2 times 2. So probably our first step should always be to simplify. And now 5% divided by 2 is 2.5%. And the exponent is 4. And when you throw that in there, if you're rounding it to dollars and cents, you should get 1103.81. It's not exactly, but if you round it, that's what you should get. Okay. Now, for part B, what numbers do we have? P is 5,000. R is 0.06. N is 4. T is 5. So once again, I'm just going to recycle this formula here and edit it. So we'll have 5,000. Let's move this over here. 5,000, 6%, but compounded quarterly. And the time frame is 5 years. So in this case, we have 5,000. Now, 6% divided by 4 is 1.5%. The exponent is 20. And so that's going to give us approximately 734.28. What's 734.28? Now, as far as the calculator goes, you can approach this a couple of ways. But, you know, if you go from left to right, you will need parentheses. If you go from right to left, if you calculate 1.015 to the 20th first, you can then simply multiply by 5,000 without parentheses. It doesn't really matter. You have to pick the approach that works for you, because otherwise you're bound to make mistakes on the exam. So make sure you're getting these same numbers with your calculator. That could potentially be a big holdup on the test. You know, if you're sitting there suddenly realizing, oh, I don't know how this works. Yeah, you got to get your hands on those keys and make sure you're getting the same numbers. All right. C. P is 2,000. R is 9. N is 12. And T is 7. And so, in this case, I'll just recycle this formula. Okay, I don't know what just happened there. Let's recycle this formula. All right, good. So we have this time 2,000, 9%, 12, and then we have 12 times the number of years, which is 7. So we have 2,000. Now 3/4, this is 0.0075 because that's 0.75%. The exponent is 84. And then that's 37, 46, 40. Okay, so that's 3746. All right, and then there's one more. P is 4,000. R is 11. Now this time, ooh, the frequency is 365 and T is 10. So that's going to be a bit of a mess, but we can do it. Okay. So let's see, how does that work? So we have, in this case, $4,000. The rate is 11. The compounding frequency is 365. Wow. And then up here, N is 365 again. And this time, though, the time is 10 years. All right, so this number here will be very small. Three zeros followed by 30137. And then the exponent is actually 3650. Wow, that's a big exponent. Let's see what that turns into. $12,014.67. Okay, so that one's done. All right. So this one, in 10 years, you're able to more than triple your money, which is kind of nice. But that's, of course, because it's daily compounding, but also 11%. That's a big rate of interest, especially right now at this point in time. So anyone would be happy with that. All right. Now in the next section, we're going to be looking at annuities. So we have to use that very complicated formula that we had along the way. It's the next step up. It's the formula that involves repeated payments rather than the principal. Okay, so let's jump down here and introduce that formula again. So how does that work again? A equals here we go. A equals, now this time we have R rather than P. R for repeated payments. And then we'll have 1 plus R over N to the NT power minus 1, all divided by the ratio of R over N. Okay, so that's our basic formula for all future values of an annuity problems. And you notice you can tell because it says the word annuity in the question, but also because these are periodic payments rather than principal. That's our R, okay? It takes the place of P. Other than that, the formula is very similar to what we've been doing. It's just a little bit messier. So here, for example, we have P equals 500. R is, oh, I said I did it again. It should be R, my fault. It should be R, not P, sorry. R is, lowercase r is 0.04. The frequency is 2, and T is 2. Okay, let's plug that in. Now, here's a case where you really, really want to simplify it as much as possible to avoid making mistakes. Okay, so you'll have 500. R is 0.04. The compounding frequency is 2. And this is a 2-year investment. Okay. So let's simplify it as much as we can. So 0.04 over 2 is 0.02. The exponent here will be 4 minus 1. And then in the denominator, 0.04 over 2 is 0.02. So what you might want to think about doing is doing what's in the brackets first. And if you do 1.02 to the 4th power minus 1 is 0.08, approximately 0.082432, that's good enough, over 0.02. And that works out to be approximately $2,060, 0.80. Okay, so you multiply that numerator by 500, divide by 0.02, and it should be 2060.80, let's say. You can round that to dollars and cents. All right, that's a little too big. Let me just shrink it up a bit. That's better. Okay, so it's roughly, I mean, you know, give or take a penny of rounding. That's 2060.80. All right, so now let me just split up the screen so we can see the table. Yes, so that's your final result. Okay, B, R equals 1,000. Lowercase r is 0.06. N is 2, and T is 5. All right. So let's plug everything in. So I'll just recycle this equation. Okay, here we go. So R is 1,000. The interest rate is 6. Compounding frequency is 2. And it is a 5-year investment this time. Okay, so then let's see what we can do over here. This is 1,000 times 1.03. The exponent is 10. Down here we have 0.03. Okay, so this becomes 1,000. And 1.03 to the 10th minus 1 is approximately 30.34. 3916. Okay, that's good enough. There's plenty more decimals, but that's plenty. You know, that's fine. All right, we'll multiply that by 1,000. Over 0.03, we're going to get about 11,463.88 when rounded to dollars and cents. All right. Part C. R is 2,000. Lowercase r is 8. And t equals 8. All right, so let's see, what do we got here? Okay, so I copied the equation, and I'll just edit it right now. Okay, so we'll sneak in the 4. Wait a minute, 4. So then in the exponent, we have 4 for n. And then the time is 8. Okay, so you got 2,000 times 1.02 raised to the 32nd power over 0.02. And so that's going to give us all right, 1.02 to the 32nd minus 1 is approximately 88. 4541, let's say. All right, and we'll multiply that out. And that's going to give us roughly 88,454.06, let's say, within rounding. Oh, here we are. Okay, so it's approximately 88,454.06. So that was C. Now D. Let's start typing in the numbers. This time R is 1,000, uppercase R. Lowercase r is 0.12. We have quarterly compounding, and T is 10. Okay, so 1,000 for R, 12% for lowercase r. This is, again, quarterly compounding, but this time it's 10 years. And then here we have 12. Okay, so what do we have now? Now, 12% divided by 4 is 3%. The exponent, though, is 40 now. So where does that leave us? 1,000. Down here I have 3. (1.03) raised to the 40th equals minus 1. 2. Oh, wait a minute, something's not right. 1.03 raised to the 40th minus 1. Ooh, well, that's a big number. I couldn't believe it when I saw this. 2.262038. Oh my God. All right, well, let's see what that turns out to be. Okay. Yeah, 75,401.06 0.26. That's perfect. All right, now in the next batch of problems, what we're trying to solve for is the effective rate of interest. In other words, EAR. So the rates that are given in this table are the APRs.
And can you just go up to C and D for a sec?
Oh yeah, sure. Just get rid of the split screen here. Here's C. Let me bring it all together here so you can see it. All right, so there's C and D right there.
Thank you.
Okay, let me know when you're ready.
I'm ready.
Okay, good. All right, so this is EAR. So if you recall the formula for EAR, straightforward compared to the ones we've just been looking at. You've got E equals all right, hold on, it's being a little stubborn. E equals, capital E, we've been using E equals, in parentheses, 1 plus R over N. And then the exponent is just N. It doesn't matter how many years this goes on for. This is an annual rate. Okay, so let's remember that E equals EAR. And lowercase r is actually the APR. And of course is the compounding frequency. That hasn't changed. All right, so that's how this formula works. So for part A, now, by the way, this rate in this formula is actually the APR. This is the lowercase r is 4%. This is the APR. And the compounding frequency is 2. That's all we need to know for this one. The time, like I said, is immaterial because this is an annual rate anyway. So let's see what we can do here. All right, so I'll just borrow this formula. And let's see. So what numbers go in here? Well, just the two of them. R is 4%, N is 2. And so when you plug that into your calculator, you're actually getting equals 1.02 squared minus 1. And that's going to give you, now for these, you can usually round them to, let's say, 4 decimals, I suppose. 1.02 squared minus 1 is 0.0404. Well, that one is easy. Yes, it's exactly 0.0404. All right, so let's see. I'll just slide this over a bit. Okay, so once again, with this information we have, APR is 4%, N is 2, twice a year. The effective annual rate, EAR, is 4.04%. So if you are putting your money in the bank, in this bank, you're actually earning 4.04% per year rather than just 4. And if you're borrowing, it's the same thing. You're paying that much. So again, it doesn't seem like a big difference, but it can pile up over the years. And the larger the APR is, the bigger will be the spread between APR and EAR. So with higher interest rates, it makes more of a difference. And that's why when you look at a credit card, you see the gap between the APR and the EAR is quite considerable. That's because they're charging you a very high rate to start with. Okay, now the R here is 6%. Part B, it's 6% semi-annual compounding. So I'm just going to, once again, I'm just going to borrow this formula and edit it. All I have to do here is change the APR. The compounding frequency hasn't changed. So this is now 6% twice a year. Okay, so so we have 1.03 squared minus 1, and that's equal to 0.0609. Okay, so in other words, again, you're actually effectively being paid not just 6%, but 6.09%. Okay, so you can see here, you notice like here, the difference is 4.04%. These are both semi-annual cases. When APR was 4%, the EAR is only 0.04% higher, but you notice here it's not 0.09% higher. So in other words, anytime APR, the higher it is, the more the difference will be between APR and EAR. All right, now for C, it's 8%, but now it's compounded quarterly. So the difference will be even larger between the APR and the EAR. Let's see how much larger. We'll just borrow this equation. So 8% 4 times a year. All right, here we go. 8, 4 for 4 years. So the exponent also changes, don't forget. The exponent equals the compounding frequency. So of 1.02 to the 4th minus 1. Let's see how much of a difference it makes this time. 1.02 to the 4th minus 1, 8 approximately. Now this one you can round it a little bit. Let's call it 8.24%. That's close enough. It doesn't have to be any more precise than that because remember, all of this is being rounded to dollars and cents anyway. So, oh, you know what I forgot to add at the end? Not that it really matters. It should be clear by now that 0.0824 is the same thing as 8.24%, but I'll throw it in there anyway. So now, if you notice, the gap between APR and EAR is 0.24%, 0.25%. That's starting to become a fairly significant difference. Then we would expect for this last one, the difference between the two will be even larger because it's a larger rate of interest to start with and it's quarterly compounding. Man. So let me edit this real fast. So it's now 12% instead of 8, but it's still quarterly compounding. And so what I have here is 3% raised to the 4th. And let's see what that is. Uh, 1.03 raised to the 4th. Minus 1, yeah, well, that's a big difference. This time, we're getting 12.55%. And so the gap between APR and EAR is it's more than 0.5% now. So now it's starting to really matter. That compounding frequency is starting to really add a lot to our return, to the savings account. That's an extra 0.5% that you're getting because they have quarterly compounding instead of annual. So I think we should all be happy about this as long as we're the lender. If we're the borrower, of course, this is going to cost us more money. Okay, but we have to know this. And so again, you know, if you go to most banks, when you look at the signs, it'll show both numbers anyway. You shouldn't have to do this yourself, but it's good to know how to do this. All right, now we've got some quick word problems. They're not very complicated, you'll see. All right, here we go. So now here we have William borrowing $10,000 to finance his senior year at SUNY Purchase, where he's majoring in the history of underwater filmmaking. If the loan is repaid in 5 years, oh, I almost forgot. Let's start with the principal, 10,000. He's borrowing the money for 5 years. And we're being told that his simple interest on this loan is $2,500. Okay, this is the case where we're looking for the rate of interest. So because the entire problem is based on simple interest, we can figure out what rate he's paying by using this formula, which, if you recall, can be rearranged algebraically, and it becomes I over PT. So therefore, R equals 2,500 over the product of 10,000 and 5 for 5 years. 2,500 is divided therefore by 50,000. And so therefore, that ratio is 0.05, which is the same thing as 5%. All right, so when you're doing this in the calculator, once again, don't forget the parentheses. You do need parentheses in that denominator. All right, otherwise you're going to get a number that's really way, way off. And in fact, you should be able to tell if your number doesn't look right. Like with interest rates, if you get something really absurd, like in this case, if you forgot the parentheses, you're going to get 125%, which clearly can't be right. So just make sure you use those parentheses in the denominator. Yes, that's what they're for. And by the way, here's another helpful hint too. If you're not sure about the parentheses, there's no penalty for using them when they're not really necessary. In other words, you can't get a wrong answer because you use too many parentheses unless you don't put them in the right place. So, you know, if you're not sure, you should probably use the parentheses. All right, now here we go. Here's another one. We have Cynthia, who's borrowing a sum of money, which we don't know what it is, for 5 years. And she's buying a car. The rate is 5%, and the simple interest is $5,200. So how much did she borrow? That means we're looking for the principal. How much did she borrow means the principal. So don't forget, the principal is the amount you either borrowed or lent. Anyway, so the principal, now remember, if I equals PRT, that implies that P must equal I over RT. So therefore, I guess I can do it right here. P equals 5,200 over the product of 0.05 and 5, or 5,200 over 0.25. And so therefore, the amount that she borrowed must have been $20,800. Okay. Now, by the way, if you're really worried about the parentheses, you can simplify it like I did right here before you do the ratio. That's up to you. You can decide whatever makes you comfortable. That's what you should do. And then always do it that way, because otherwise, you know, it increases the risk of making mistakes. All right. Now, how about 8? So now Ralph is setting up a business to sell smoothies, all right? But he wants to offer flavors that are not available anywhere else. And he finds that some of his best sellers are peanut butter and jelly smoothies, avocado and anchovy smoothies, and horseradish and honey smoothies. Interesting. Okay. So now Ralph, in order to finance this business, he borrowed $100,000. That's our principal. Yeah, but you know what? If he's making money, what's the big deal, you know? Okay, so I'm telling you, he's getting some strange requests, and so he suddenly decided, you know what? If you're willing to buy this stuff, I'm going to sell it to you. But remember, the focus of his business is on what, I mean, the name of the business might be smoothies that you can't get anywhere else. Yeah, I don't know. No, Ralph is just selling them what they want. There's nothing strange about Ralph. The customers want these smoothies. He's going to give them to them because that's what they're asking for. It's the customers we have to wonder about. But yeah, I mean, peanut butter and jelly might actually be kind of cool, but I don't know. The honey might smooth out the horseradish, and same thing over here with avocado and anchovies. It's possible. Who knows? Why don't you try it? I think that's what happened. They became like they liked it so much that now every day they need a smoothie. Avocado and anchovies is now like the big bestseller. We don't know. I don't know. Maybe one day he ran out of other materials and he said, "Here, try this. See if you like it." That's a very strong possibility. Some of the foods, at least that we know and love, were created by accident, like waffles, apparently, or not waffles. Ice cream cones. Apparently, somebody ran out of whatever he was doing, and he decided, "Why don't I put the ice cream in these waffles?" And then the idea caught on. Yes, you never know what the public will like. Yes. But you know what? As a business person, your job is to give them what they want. That's it. You don't ask questions. You give them what they ask for. Even if you have to hold your nose while you're making that smoothie, that the customer wants that, so you give it to them. Okay. All right. Well, anyway, so P is 100,000. The rate of interest is 7%. And the simple interest is 35,000. And so what we don't have is the principal. So therefore, we know from here that we're just going to calculate it as I over RT. And so what does that equal? Oh, wait a minute. No, my mistake. I just realized, no. I misread it completely. It's T. Sorry about that. I was completely not paying attention to the right part of the question. He borrowed 100 grand. So therefore we're solving for T, not for P. T equals P over IR, like we had up here. Oh no, we didn't have that one yet. This one was interest. This one was principal. So now we're solving for the first time. T equals I, oh no, I wrote it wrong, sorry. I over PR, that's better. Okay, now we're finally all set. T equals I over PR, which means 35,000 over 100,000 times 0.07, which you could rewrite if you want to as 35,000 over 7,000. And that just tells me that Ralph borrowed the money for 5 years. All right. So that's it. So we're done with this. So I'll post it on Moodle, of course, and then the test, I'll put it up there, and I guess we can agree that it should be ready, let's say by next Monday night at midnight. Now, this one is not as long as the first one either. It's only about 10 questions. So I think you'll be pleasantly surprised by how short it is. So it should be no problem at all. Yeah, compared to the other ones, this was quite nicely short. The next one will be a little longer, but not maybe as long as the first one. The final exam is only based on 2 chapters. Maybe it'll be comparable to the first test, but this one, it's sort of like a break in the middle where you just have the 1 chapter. So yeah, it's kind of a standalone topic. I didn't think it made sense to. Oh, didn't you get yours? Oh, if not, then there's something wrong. I'll have to write to you separately. There were 1 or 2 of them that were either in the wrong format. Like somebody sent me one that's in pages, I think, and I couldn't read it. And so I'll get back. There's a handful of people that I have to get back to about it. If you look in the Moodle, though, there's a grade book. And first check and see if it's in there. I put them all in the grade book, and I thought it was going to send out emails when they were done, but apparently not. So first look in there, and if it's not there, then send me an email. that means either something was wrong or else the formatting was wrong or I couldn't read it. And so you may just have to resubmit it. I did all the ones where there wasn't a problem. Okay, there's still a few that I have to catch up with, and I don't remember if yours is one of them or not. Okay, so if you don't have a grade, first check the grade book on Moodle, and if it's still not there, then you are probably falling into one of those categories where either it's not a format that I can read, or else, or possibly something was missing. That happens sometimes too. Like I've had that happen where people Xerox their notebooks or take pictures, and then they accidentally forget every other page. That does happen sometimes too. So I'll first double check, and then if not, just send me an email. All right, so this one is done. So we can get back to 11, our discussion about probability theory. And so I saved the most complicated rule for last. You might recall that we defined 3 rules of probability that we want to study. And let's see if I can find the list here. Yes, there were the 3 of them. The first 2 were fairly straightforward. And the third one is the one that's the most complicated, so we saved it. Here it is. Addition rule and complement rule we're finished with. And if you notice, especially the complement rule was very straightforward. The multiplication rule is a different category altogether. We're going to need to introduce some more background before we can approach this thing. But along the way, we'll get more practice, which is always helpful. So let's do this right now. And I think when we're done with the complement multiplication rule, I think we might be done with this chapter. But all right, let's check this out. So the multiplication rule oops, no, we have to start further back here. Okay, so in order to define the multiplication rule, we need to introduce a brand new three actually brand new concepts, which will introduce in the form of an enormous example that we'll work through from start to finish. We're going to need to define what are called conditional probabilities. And the word conditional suggests that this means that the probability of one event depends on whether or not another event is true or false. So it's like, let me see if I can think of a good example of this. Let's say you wanted to know the probability that a farmer's profits reach record levels this year. No, that question will depend very heavily on whether or not the weather was good this year. So you can imagine that the probability of the farmer's profits reaching a record level depends on knowing whether or not the weather was good this year. So that becomes a conditional probability. And we also have the concept of what are called joint probabilities, which involve 2 or more events. Okay, so what we're going to do is introduce an example here. We're going to have a table, a very special table, which is referred to in math as a joint probability table, where we take a group of observations and break them up into categories. 2 basic categories, that is. So this table will consist of all the probabilities that we need to formally define our multiplication rule. So the table has 2 types, which are known as joint probabilities, as we just saw. And the second type has 2 equivalent names. They're called marginal, or sometimes they're called unconditional probabilities. All right, so here we go. So the example itself is pretty straightforward, but it contains a lot of new information that we haven't seen before. All right, so what's going on here? Imagine yourself. Now, by the way, everybody knows that SUNY Purchase is meant to be a performing arts school. They do not have a business school, which many colleges have a business school as part of their many offerings. Purchase does not, but many colleges do. And within that business school, you see the traditional types of majors being offered. For example, as you can see in this example, we have finance, accounting, and marketing. We don't have that here, but although the school does have economics, that's one thing they do have in the business area, but they don't offer the traditional business majors like finance, accounting, and marketing. But whatever school this is supposed to be has a business school. And within that school, they have, we're assuming, just 3 majors. And then there's also degrees, 2 different types of degrees. BBA stands for Bachelor of Business Administration. And basically, it just means that it's a college degree. In other words, what you're all working on is a bachelor's degree of some kind. It might be a Bachelor of Arts, it might be a Bachelor of Science. There might be other more specialized ones. I'm not really familiar with the way the degrees are categorized here, but no matter what it is, it's a bachelor's degree. That's the first 4 years of college. When you're done, you'll have a bachelor's degree in something or other. And but what comes after that is the graduate level, where you can get a degree called MBA, which stands for Master of Business Administration. Now, in order to get into this program, you have to already have a college degree, because this is what we call a graduate degree, meaning it's what comes after college. All right, so if you're an MBA program, it means you already have your college degree and you're now going on for another degree beyond that. Now, you might say to yourself, who in their right mind would want to do this? But MBAs typically get paid a lot better than BBAs, okay? In other words, this is a good way to punch up your salary if you're working in this area. Now, I don't know if Purchase has graduate degrees or not. I think they may have a few. It would be things like Master of Arts in, let's say, I don't know. I know they offer art as a major, and they have a lot of different performing arts. I'm not that familiar with their offerings, but I know they have at least a few master's degree programs. And again, so those are the ones that follow up after college. So let's say you've decided that you can't get enough of your major. Let's say you're getting your bachelor's degree in history, and you say, oh, I love this stuff so much, I want more. Then you would go on and get a master's degree in history. And if you're really crazy about school, what follows up on all of that, just as an aside, which is not in this table, after that level, you reach what's called the doctoral level, where you get a degree called a PhD or something related to that. And so all your faculty members, most likely they all have PhDs. If not, they probably just have mountains of experience in that discipline, because not every discipline offers a PhD. Like if you're in the dance department, it's not likely that anyone there has a PhD. I don't think they even have a PhD in dance, but most of the disciplines will offer that level. And that's what comes after the master's degree and the bachelor's degree. So if you're going to go to that level, you really mean it. I mean, you've got to be super serious about education, but you do require this to end up teaching in a college. So it exists. It's out there if you're interested, but it's going to be a long time before you start thinking about it, because there's a couple of other hurdles you have to get past to get to this level. So in this business school, though, MBAs are a very popular major for business schools, because the nice thing about this is, unlike many master's degrees, Like, let's say you do want to get a master's degree in, let's say, English. Most likely they'll require you to have a bachelor's degree in English to get into the program. But with MBA, you can pretty much get in there with any major because their plan is to teach you all of this stuff from scratch anyway. So in other words, it's one of the few master's programs where you can dive right into it no matter what your college degree is. But anyway, enough of that. So that's what you're seeing in this table. You've got all these, in this first row, these are all college students who are getting a bachelor's degree in business administration. And down here, these are what we call graduate students who are getting their MBA in these different disciplines. And of course, you can see we've got the three majors, which are finance, accounting, and marketing. So everybody in this table, everybody in this business school, of which there are 500 students, has to fall into one of these categories. Okay, now, so we're going to use letters to represent all this information. It'll be that much simpler. So B from now on means this is a person who's getting a bachelor's degree or BBA. M means that the student is getting an MBA or a master's degree. And then we will do something that's equivalent to that with all the majors. There's just one problem, one awkward, unfortunate coincidence. If you look at this table, what do you notice about the majors? Well, oh no, marketing starts with an M. So we have to do something different for marketing. So here's what we'll do. Just as a compromise, F will represent getting your degree in finance. A will represent getting your degree in accounting. So we'll let T represent marketing. Okay, so I hope that won't be confusing because M is already taken for MBA. So there's 5 events that could occur in this table. Bachelor's degree, master's degree, finance major, accounting major, marketing major. So all that information can be used to help us calculate probabilities. So you imagine the following situation. What if I randomly pick somebody out of this student body? Let's say the school has decided that they publish an alumni magazine every month, and they decide to randomly pick somebody from the business school for this month's cover. So what we would like to do is calculate the probability that they have one of these characteristics. So for example, and by the way, when we calculate a probability for 2 different things being true at the same time, for example, the probability of A and B, which we saw with the, as part of the addition rule, this type of probability is referred to as a joint probability. Joint meaning both A and B are true. So this A and B is a joint probability because both A and B are true. Or at least we're trying to find out the probability that both of them are true. Actually, I'll tell you what, let me reword that a little. It's a joint probability because we want to know the probability that both A and B are true. So the terminology that we use here is that this is a joint probability, meaning the probability not just of A, not just of B, it has to be both. Okay, both of them have to be true for what we're about to do. All right, now with this table, there are several joint probabilities that we could calculate. How are they going to work? For example, let me show you one. What if I wanted to know that the person I randomly chose for this cover of this alumni magazine is getting their bachelor's degree in finance. That's a joint probability because we're asking two things at once. What's the probability that they're getting a bachelor's degree? And what's the probability that they're majoring in finance? Okay, so how would that work? Well, if you look at the table, you'll notice a couple of interesting things. How do you know how many students are getting a bachelor's degree in finance? Well, you can see here that I've written it for you that it's 130, but how do we know that? Because this is at the intersection of the row containing all the bachelor's degree students and the column containing all the finance majors. So everybody in this cell qualifies because they are both a bachelor's student and majoring in finance. The entire student body contains 500 students, all of whom are equally likely to be chosen. So therefore, we conclude that the probability of B and M is 130 over 500 0.26. So 26% is the probability that when I pick somebody randomly from the student body, that they are getting a bachelor's degree in, oh, I wrote the wrong thing up here. Sorry, this is B and F. No wonder. Bachelor's degree in finance, that's better. So B and F. Remember, this intersection symbol means the same thing as and in English. So it's the bachelor's and a finance degree that we're looking for, and that's right here. And this is known as a joint probability because it requires two things to be true. All right. So this is what we mean by a joint probability. And there's others that you can see in this table that we could ask about. Let's see, what do I have next here? Oh, I set up a table in here somewhere with all of them, but let's just figure it out for ourselves. Okay, let me just for the fun of it, let's try our hand at a couple of these. Hold on one second, and I'll bring back the table. What is the probability that a randomly chosen student is getting an MBA in accounting? Okay, now actually, if I do this carefully, I just might be able to sneak the table onto this slide. Hold on one second. I think I can pull this off. Space is always a problem when you're dealing with these slides, but let me try this. Oh my God, that could not have worked out any more convenient, except that this is no longer bold-faced because that's not what we're looking for. All right, so how in the world? Whoops, what am I doing? Hold on. Try not to give it away. In fact, you know what I'm going to do here? I'm going to do a few more of these because it's so convenient. All right, hold on one second. Oh, I like this. Okay, here we go. So let's get back to it. So once again, so the 500 doesn't change. The total is always the same. What's the probability that a randomly chosen student is getting an MBA in accounting? How would you figure that out? Well, this is equal to, oh man, that's even better. Ooh, I like this. Because there's room. All right, hold on. Let me fiddle around with this for a second. All right, so now we're ready to tackle this. So MBA in accounting, the symbols that we will use is M and A. So we're looking for all the MBA students, which is the second row, and the accounting majors. Look where I found it. MBA and accounting. So that means it's 35 out of 500. 7%. Okay. So that wasn't that hard, was it? No, it was not. So let's try another one. Except this time, let's try getting a bachelor's degree in marketing. All right, so we just have to ask ourselves, and hold on, let me just copy this a couple of times. Okay, great. All right, hold on, let me get back to where I was. Oh, see, I'm trying to make this thing too perfect, and I'm wasting my time here. No, I guess there's not enough space for everything. Well, that's not bad. All right. So anyway, here we go. Let's get back to it. So anyway, yes. So we've already done bachelor's degree in finance. 26%. So master's degree in accounting is 35 out of 500 or 7%. How about bachelor's degree in marketing? Okay, that means bachelor's degree, the first row, marketing, 90 out of 500. So we write this as B and T. Remember, T is marketing, 90 out of 500. 18%. Okay, so you can see they're all basically done the same way. What you're looking for is the intersection of those two characteristics, in this case, bachelor's degree in marketing. Whatever that number is, we divide now by the total number of students in the student body. And so we conclude that there's an 18% chance of randomly choosing somebody who's getting their bachelor's degree in marketing. All right, maybe we could do one more of these just to make sure we really get it. How about getting an MBA in finance? We haven't done that one yet. So the symbols would be, and by the way, I just want to mention here that when you're dealing with intersections, the order in which I write these letters doesn't make any difference. I could just as easily have written F and M. It means the same thing. So just be aware of that. The order in which I write these letters is not relevant. So M and F means all the MBA students down here studying finance. Which is 9%. Okay, so they're all the joint probabilities are done in exactly the same way. And so I've got a table with all of them listed here if you want to go back and double check them all. And they're all done the same way. So now there's another important type of probability that we could ask ourselves with this table. So let's investigate it. What about something like this? Well, first, the name of this next group of probabilities is marginal or unconditional probabilities. They have two possible names. It sounds more complicated than it really is. You'll see what I mean in a second. So once again, suppose we reach into the student body and randomly choose somebody for the cover of the alumni magazine. And this time, I just want to know, what's the probability that this student I've chosen is getting their bachelor's degree? I don't care what their major is. I just want to know if they're getting a bachelor's degree or not. Now, this time, that means I'm including all the bachelor's degree students. And it turns out there's 400 of them. And of course, the student body is 500. Therefore, that implies, if you look at this carefully, by adding these all together, I've got 400 bachelor's degree students divided by 500 total. Therefore, this probability must be 400 out of 500, which is simply 0.8. But another thing I want to point out here is that the symbols that we're using, we don't need, they're not joint probabilities. This is just straight ahead probability of B. Okay, so what about this one? What if I want to know the probability that a randomly chosen student is majoring in accounting? And again, I don't care if it's a bachelor's student or a master's student. I just want to know if they're majoring in accounting. And so this time, what I'm focused on is the total number of accounting students. And so what I've got here is 215 out of 500. So again, remember, this is a marginal or unconditional probability. Only one thing is true, and it does not depend on another event. Okay, so let's try another one. What is the probability that a randomly chosen student is getting an MBA? Well, that's pretty easy because, oh boy, let's fix these titles. There we go. That means I'm only interested in this row right here, only MBA students. 100 out of 500, 20%. And so that's all you have to do. We're not asking about the major. We're only interested in the level that they're studying at. All right, let's do one more. I think that will do. How about the randomly chosen student is majoring in marketing? Okay, so in that case, what we're after is all the marketing majors, regardless of whether they're getting a bachelor's or a master's. And that turns out to be 22. 110 of 500 is 22%. There we go. All right, I think there's enough of that. Now, all of them are listed here. And yes, so I've prepared this chart where I put all of the probabilities in here. Now, if you look at this table very carefully, you'll see what's different is that instead of having the actual number of students and then having to divide by 500, this table actually has all of the numbers already divided by 500. So you might recall that the probability of BNF is 26%. With the original table, we had 130 over the total of 500. This table doesn't have the original information, but it does have the probabilities. So in other words, in fact, let me go grab the other one so that you can see them side by side and just remind yourself what it looked like in the first place. I don't know if they'll both fit, but I'm going to give it a shot. Ooh, it's really close. Yeah, just about. Okay, I just wanted you to see how the two tables are really the same thing, except in the top case, we have the original data. Down here, everything has been divided by 500. Now, the advantage of the table on the top is that you actually know the numbers. In other words, if somebody said, how many bachelor's degree students are there? I can't get that information from the bottom table, but I can tell you the probability of choosing a bachelor's degree student. So both tables have their places, but I would say that for us, the one on the bottom is probably the more useful of the two. So we'll probably stick with that approach going forward, but just be aware that they both mean the same thing. All right, so there's one probability to go, the one that we've been waiting for, the one that actually makes it possible to define for the first time the multiplication rule. But because it's a fairly complex concept, I don't think it's a good idea to start it right now. So here's what we'll do. We'll stop right now. I'll post the exams this afternoon. And, you know, what you should do is download it and start working on it. You can have a week like the last time. And the usual, take pictures, send it back to me by email. And on Thursday, we'll just pick it up where we left off right here with the rest of chapter 11. And most likely we'll start chapter 12 as well, which is our introduction to statistics. All right, so if there's no last minute questions, what we can do is just meet up again on Thursday.
Thank you.
Hey, see you next time.
Thank you, Professor.
Thanks.
All right, bye.